In class today, we introduced the basics of confidence intervals. So this is just to reiterate what we learned in class today and provide a few more examples for you. In chapter 7, we knew the population parameters. And we were able to use those to make our conclusion. In chapter 8, we don't know that information, and honestly, and beyond the chapter 8. So we don't know the population parameters, so we have to rely on the sample data to estimate the parameter. So we're going to rely on the statistics that we get from our sample to make an inference. And this is called inferential statistics. So we use a point estimate to estimate about the population parameter. So a point estimate is a statistic used to estimate a parameter. And it is called that because you're literally using it. It is a point value inside an interval that's used to estimate about a parameter. So it's called a point estimate because it is a point inside an interval. And more specifically, it'll be a point inside a confidence interval. So let's take a look at this example. A student project put this question. They took 172 undergraduates and said, you witnessed 2 people cheating on a quiz. Do you go to the professor? 19 of them said yes. So that would be a proportion. That's a sample proportion. 19 out of 112 people say yes. That's about 11%. So that's our p-hat. We are going to use this p-hat to estimate P, the proportion of all students who would report cheating. Of all students who would report cheating. And of course, that p-hat is not going to be exactly equal to p. There's always a chance that it's going to be different. So we never expect that the p-hat or the x-bar, whatever the statistic, we don't expect the statistic to be exactly equal to the parameter. So we create an interval of plausible values. And we use the word plausible instead of possible because possible could be anything, but plausible is like a likelihood. So plausible values is more specific than possible values of the parameter. All right, so we've got an interval of plausible values, and what the formula looks like is it's going to be your point estimate plus or minus the margin of error. The margin of error gives you the width of your interval. So you've got this interval with endpoints, and then your point estimate is in the middle, and this distance from the center to the edge is your margin of error. So we include a margin of error because it accounts for the variability due to random sampling. So let's look at an example at the bottom here of your page. A news reporter reports the results of a survey and states that 45% of those surveyed responded yes, with a margin of error plus or minus 5%. So if I wrote that out, 45% plus or minus 5%, my interval is going to be 40% to 50%. So that means we can expect the exact or the population proportion or percent, the true percent, to be between 40 and 50%. Okay, that should be like there, 40%. Now, if I wanted to be more precise, I would make my confidence level lower, because using a wider interval, I'm more likely to get my answer right, but it's not always going to be helpful. So the wider your interval, the more data you include, so your interval is wider. That's not always helpful. The wider your interval, the more data you include, so your interval is wider, thus making it more likely that you capture the true value. So if I wanted to make a wide interval, I would pick a 98% confidence, because that's going to have your widest interval. So let's talk about interpreting a confidence interval. There's a standard form I want you guys to use. We are whatever percent confident that the interval blank to blank captures the true, important, parameter in context. Make sure you put it in context. So let's look at this example here. You've got a poll that said the proportion of Americans who support the death penalty is 63% plus or minus 4%. So it's 0.63 plus or minus 0.04. So my interval is 0.59 to 0.67. So between 59 and 67% of Americans support the death penalty. And we are 95% confident of that. We are 95% confident the interval from 0.59 to 0.67 captures the true proportion of American adults who support the death penalty. And that's how you would interpret the confidence interval. Now let's take a look at interpreting the confidence level. So the confidence interval is just interpreting what that interval, the single interval you have, means. But the confidence level is whatever percent you are. So if you say you're 95% confident, what does that actually mean? What does the 95% mean? So whereas interpreting a confidence interval, you're interpreting the actual interval itself. The confidence level, you're interpreting the percent. So the way you interpret that is in repeated samples of size n, blah blah percent of the resulting intervals would contain the true parameter, and you've got to put that in context. And that will be how you interpret the confidence level. And there's an applet you can go to that you can simulate doing many samples and showing what percent of the intervals capture that true value. If you want that link, let me know, and I'll give it to you so you can test it out. It's the one we did in class. So let's look at this example. This company is worried that its employees are in poor condition, so they decide to count how many steps they're taking a day. So they take 50 randomly selected employees, and they report with 95% confidence that they take somewhere between 4,547 steps and 8,473 steps. That's your confidence interval, and our confidence level is 95%. So for part A, we're going to interpret the confidence level. And so we're going to say that if I were to repeat this sample of size 50 many, many times, 95% of those confidence intervals would contain the true number of steps that the employee takes in a day. So I'll say that again. In repeated samples of size 50, about 95% of the resulting confidence intervals would contain the true mean number of steps that the company's employees take. That's the confidence level. So now we're going to interpret the interval itself. So the first one was, what does it mean to be 95% confident? That's the confident level. And then part B is the actual confidence interval. So you would say that we're 95% confident that the true mean number of steps the company's employees take is between 4,547 and 8,473. Or you could also mention the interval first and then what it estimates. That order doesn't matter as long as you have all the words. So we're 95% confident that the interval from 4,547 steps, use that unit there, to 8,473 steps captures the true mean number of steps that the company's employees take. So we've interpreted the confidence level, we've interpreted the confidence interval. Now we are going to find the point estimate and the margin of error. So the interval here is 4,547 all the way to 8,473. The point estimate is our sample mean that goes right in the middle. So to find that, we would do the midpoint and we would add these together and divide by 2, and you get 6,510. So the point estimate is our X bar, which is 6,510 steps. The margin of error is the distance between those. So you can just subtract that. Margin of error is going to be 1,963 steps. So let's look at part D now. Recent guidelines suggest that people aim for 10,000 steps per day. Is there convincing evidence that the employees of this company are not meeting the guidelines on average? So my interval only goes up to 8,473. So that means the true average number of steps my employees are taking is less than 10,000 steps, no matter where inside that interval I fall. So because my entire interval of plausible values, interval of plausible values is below 10,000, there is convincing evidence that the company is not meeting guidelines. Is not meeting the guidelines. We're going to talk about the actual formula for getting a confidence interval in section 8.2, so stay tuned for that. We'll do that in the next video. So in general, we want to try to find a healthy balance between a wide interval but an accurate interval. You want it to be wide enough to capture the true value, but not so wide that it's not helpful. And so there's different ways that you can reduce the margin of error, and there's different reasons that we would want a small margin of error. So there's a couple ways to reduce the margin of error. The first one is to reduce the confidence level. If you reduce the confidence level, your interval is going to get narrower. So your interval will be narrow. So it is going to be a smaller margin of error, but you can be less accurate. So likely to not actually capture the true value, the parameter. The other way to make your interval smaller or to make your margin of error smaller is to increase sample size. That's probably the easier way to do it or the more accurate way to do it, but sometimes it can be inefficient or tedious. So it's all about having that healthy balance there. There's two things you have to remember when making confidence intervals though. You have to have a random sample because remember, the margin of error accounts for random sampling or variation due to random sampling. So you have to have an actual random sample. So if you don't have a random sample in the first place, then the margin of error can't account for anything. It cannot affect the bias, only the variation due to random sampling. So the margin of error, the confidence level, the sample size, none of those things affect the bias, only the variation due to random sampling. You've got one more example here at the bottom of your notes for 8.1. Give that one a try and then check the answers on my portal and see how well you did. Stay tuned for section 8.2.